Hi, in this video we will discover the strategy button. First, let me introduce the team. The team includes Lê Anh Kiệt, Lâm Kim Nhân, Lê Võ Huỳnh Thanh and Trần Thiên Hoàng. In this tutorial, we will go from the surface to the deep parts of strategy by leading you through a symbol and definition about it. Let's start. For a simple example, let's think about making a farming game. In that game, you are only allowed to plant a ton of trees at once on that field. The behavior of player to the field are unchanged, only change the time of tree. So, how can you write that?
If we write the same code for each tree, but only change the tree types, then after a long time, your code will become too complex. And it's even more complex if we had type of fertilizer.
At this point, the amount of code you need to write is fairly large. It's calculated by the formula on the screen. This caused by having too many same part of code.
So, how can we do that in the correct way?
The solution here, we will make the interface for tree time, and a tree time is an implement of that interface. We will use that interface for planting tree on that field. I will provide you the code of it. On this screen, we will see that every time of trees is inherited by the strategy lat at the interface. So that a time of tree is a strategy. This will enable the user use whatever tree they want to plant on that tree by just choose a strategy.
Through practical problem, you can see that design patterns are very common in our daily life. So, what are design patterns? Design patterns are typical solutions to common occurring problems in software design. They are like free blueprints that you can customize to solve recurring design problems in your code. You can just find a button and copy it into your program, the way you can with up the cell function or library. The button is not specific, of course, but a general concept for solving particular problem. You can follow the button detail and implement a solution that suits the variety of your program. Patterns are often confused with algorithms because both concepts describe the typical solution to some no problems. While an algorithm always defines a clear set of actions that can achieve some goal, a pattern is more high-level description of a solution. The code of the same pattern applied to two different programs may be different. What does the pattern consist of? Most patterns are described very formally so people can reproduce them in many contexts. Here are selections that are usually present in pattern description. Intent of the pattern by description both of the problem and the solution. Motivation further explain the problem and solution that the pattern makes possible. Structure of blocks so each part of the pattern and how they relate. Code example in one of popular programming language make it easier to grasp the idea behind the pattern. There are three main types of design patterns. Relational design pattern, structural design pattern, behavioral design pattern. We will divide into the strategy pattern and related class in the behavioral design pattern.
Our main research on the design pattern is strategy pattern. Now we will move to the definition of strategy. Strategy is a behavioral design pattern that lets you define a family of algorithms, put each of them into a separate class, and make the objects interchangeable. Now, in-depth knowledge, a class that does something specific in many different ways. We can extract this way into separate class. The original class called context must have a field for storing a reference to one of the strategy. The context represents the work to a linked strategy object instead of executing on its own. The context is not responsible for selecting an appropriate algorithm. Instead, the client passes the design pattern to the context. All strategies will be composed in the same interface and only expose a single method for triggering the algorithm encapsulated within the selected strategy. In this way, the context is independent. You can modify algorithms without impact the context or other strategy. How to implement the strategy pattern? Step 1. In the context class, identify an algorithm that runs to frequent chance. It may also be a massive conditional that selects and executes a variant of the same algorithm at runtime. Step 2. Declare the strategy interface common to all variants of the algorithm. Step 3. One by one, extract all algorithms into their own classes. They should all implement the strategy interface. Step 4. In the context class, add a field for storing a reference to a strategy object. Provide a setter for replacing value on that field. The context should work with the strategy object only via the strategy interface. The context may define an interface which lets the strategy access its data. And finally, the client of the context must associate it with a suitable strategy that matches the way they expect the context to perform its primary.
To apply the strategy pattern to the problem, step 1. We need a problem. Imagine we have a student information list. Depending on the case, we want to sort by name, ID, point, date of birth, blah blah. We know we can't write code for each case because it took too long, and in the future, maybe we need to change the sorting algorithm and we must change up them. The strategy pattern is a solution. Now, make a problem. We will create student list, but before creating list of student, you need creating student. In this class, we have name, ID, and date of birth. In class date of birth, we have day, month, and year. I will set it equal 1. Day of birth, day, okay. And we need floating point.
In this class, we create list to store student list. Make function for post new student. And another function for print student list. Done. Now we make interface for strategy. I name it a I compare. It has only one virtual function, is compare and resource boolean. We declare variable I compare in this class. And in here we need function for set compare. Because we want sorting student list, so we need sort function. I will use quick sort algorithm. You can find it in the internet, so I will not talk about how it works in this video. You can see in here. Condition is the result of the comparison function. This is the crux of this pattern. While sort function, it will call quick sort. It make clean code. Now we create class that inherit from interface. In here we have four class: compare name, compare ID, compare day, compare point. You can see how it works. talk detail how it works. So this is a UML object pattern. We will write main function for the achievement. Like you seen here, we have input file, so I will read data from it. Sort by ID and print. Ta-da! Ta-da! Ta-da again! Finally, ta-da!
Through the symbol, can you see the pro and con of strategy button?
Now, let's move to the part of strategy button. Firstly, it's very easy explainable. Why reduce conditional statements in your code? In addition, you can swap algorithm used inside an object at runtime. It also isolates the implementation details of an algorithm from the code that uses it. But not least, change easier to hazard relationship from inheritance to composition.
The con of it here is algorithm that rarely change, so it no need to come along with the pattern, and the user must be aware of on the strategy to choose the right strategy for the right situation. Many programming languages today have functions that let us use strategies so that we needn't to write it. Okay, so after we cover the definition and some example, do you know when we should use it? The strategy pattern let you indirectly alter the object behaviors at runtime by associating it with different sub-objects. We can perform specific subtype in different way. The strategy pattern let you indirectly alter the object behaviors at runtime by associating it with different sub-objects. We can perform specific subtype in different way. So you can use the strategy when you have a lot of similar class that's only different in the way they execute some behaviors. Furthermore, the strategy pattern let you extract varying behaviors to separated class hierarchy and combine the original class into one, thereby reducing the duplicate code. So you can use the pattern to isolate business logic of a class from the implementation detail of algorithm that may not be as important in the context of that logic. And the strategy pattern let you isolate the code, internal data, and dependency of various algorithms into the rest of the code. Various clients get a simple interface to execute algorithm and switch them at runtime. So you can use the pattern when your class has a massive conditional operator that switch between different variants of the same algorithm. Finally, the strategy pattern let you do away with such a conditional by extracting all the algorithm into separate class, all of which implement of the same interface. The original object delegates execution to one of the objects instead of implement on variants of the algorithm. After all, we can see that the strategy pattern is very convenient for you. But to use this correctly, we must know about the relation of it with other buttons. The brick, the state, and the strategy button and some degree of adapter a very similar structure. Indeed, all of these buttons are based on composition, with delegating work to other objects. However, they also the different problem. A button isn't just a recipe for constructing your code in a specific way. It can also communicate to other developers of the problem that the button solves. The command and strategy might look similar because you can use both of it to parameterize an object with some action. However, they have very different intents. You can use the command to convert any operation into an object. The operation parameter become view of that object. The conversion let you defer the execution of the operation, queue it, store the history of the command, and send the command to remote service, and more. On the other hand, the strategy usually describe different way of doing the same thing. Let you swap the algorithm within a single context class. The decorator let you change the skin of an object, while the strategy let you change the good of it. The template method is based on inheritance. It lets you alter the part of an algorithm by extending the part in subclass. Strategy is based on composition. You can alter the part of the object behaviors by supplying it with different strategies that correspond to that behaviors. Template method work at the class level, so it's stated, while the strategy work on the object level, letting you switch behaviors at runtime. State can be considered as an extension of strategy. For patterns are based on composition. They change the behaviors of the context by delegating some work to helper object. The strategy make their object completely independent and unaware of each other. However, state doesn't restrict dependency between concrete states, letting them alter the state of the content at will. So, some practical application. Imagine that we have a student information list. Depending on the case, we will want to sort by name, we want to sort it by ID, we want to sort it by point, by day of birth, and many things like that. We know we can write the code for each case because it took too long. In the future, maybe we need to change the sorting algorithm, and we must change all of them. So the strategy button is the right solution for you. Thanks for watching the video.